Vectors. In last video, we learnt about representing the position of a single point with variables. Then we talked about dimensions and the types of coordinates. If you have not watched the previous video yet, then you should probably go take a look. In this video, we will learn about the fundamental and principles of vectors and their representation using multiple points. Imagine a point P connected by a line with the origin. This line is called the vector of point P. This vector has a magnitude and direction. We talked about calculating these in the earlier video. The magnitude is equal to the distance between the origin and the point. The direction is equal to the angle between the origin and the point, and they can be calculated using the following formulae. Usually this vector has its tail at the origin, so we represent it using a matrix. In this matrix, the x component is written in the first row and the y component is written in the second row. But these can also be written as multiples of two unit vectors I hat and j hat. I hat is a vector with its tail at the origin and its head at x equals 1 and y equals 0. J hat is a vector which also has its tail at the origin but its head is at y equals 1 and x equals 0. These are helpful when we are using local and normal spaces, but that's a topic for another video. Now that we know about vectors, we can keep going on. Take 2 points P0 and P1, connect them with a line. Now take a point P which lies on this line and its position is determined using a single variable t as it is moving along a single line in a single direction. If the value of t is 0, the point is at P0. If the value of t is 1, the point is at P1, and any value between 0 and 1 is a blend between the two. This is called linear interpolation or LERP for short. The LERP function can be written as 1 minus t P0 plus t P1, where 1 minus t and t are the weights of the points. But we are not limited here. We can keep adding points until we form different shapes of our desire, like triangles with 3 points, rectangles with 4 points and 4 lines, octagons with 8 points and 8 lines, and more. And usually we do not show these points. This makes the shape more visible. You can also use the flood fill algorithm to fill the shapes with a color. In the next video, we will talk about how to represent colors mathematically. And in some future video, we will talk about making smoother paths like circles without placing each one of the hundreds of points yourself using Bezier curves and splines. If you want a much deeper understanding about linear algebra, which was mentioned earlier in the video with I hat and j hat, then you can watch this series by 3 blue 1 brown and you will understand where these unit vectors come from and how they are used in mapping.